Hi, this is Atlas and this is Understanding a Payload's Life Part 3. In this one we are going to see payload executables. So we know that Metasploit uses cell code for a lot of things. Cell code is very handy because we can use it for exploits, for process injection, post-exploitation tasks, and also we can execute cell code from executable files, which are commonly known as cell code loaders. Okay, of course, Metasploit automates the process of generating those executables. And the process is something as easy as this. The first thing that Metasploit does is creates the cell code, for example, a Meterpreter cell code, and then inserts the cell code into a specific executable template. Okay. The main two formats we are going to see are scripts like PowerShell or compiled binaries like PE files such as exe or DLL files. These templates are stored within the data templates folder. I can go there. OPT, Metasploit, embedded framework, data, and templates. So here we see all the templates that Metasploit uses. These are the ones compiled, precompiled, and the scripts. Yeah, we have some of the scripts here, and yeah. So this is the directory where all of them are placed. If we check all the exe ones, we see that we have ones for the 64-bit exes, 32-bit exes. Ones are intended for service exes, others for the regular exes. And there's also this old one, which is for legacy settings. And yeah, so those are the templates that Metasploit uses. And this automation is implemented by this class, MSF util exe. It implements all the logic, and the abstraction is via this function, toExecutable format, which is shared between everything within Metasploit. When you use MSF Venom, when you use RPC, or when you use payload modules like use, Meterpreter, blah, 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 reverse HTTPS, everything ends up using the code of this class. Okay, so we're going to see a little bit of that file here, the exe Ruby file. And if we search for when exe, we end up in this toExecutable format function, which gets the architecture, the platform, the code, format, and different settings. Okay. By checking the exe, we see if you select exe as the format and you select 64 as the architecture, for example, you are going to use, or Metasploit is going to use this function, the win84pe function. And if we go there, it sets the default template by default, which we see is the template x64 windows.exe. This one. And depending on the settings you have chosen, if you have choose inject, is going to use the segment injector class. Otherwise, it's going to use by default the segment appender. Okay. So let's start with scripts. For scripts, it's quite easy. Okay, we have the code, and the code is dynamically run by the script, the language, the runtime. So yeah, Metasploit only needs different templates with different placeholders. Okay, and those placeholders are replaced by the final data. For example, for the PowerShell script here, we see that the code of the payload is encoded with base64, and it is inserted within the variable where this placeholder is located, v64 cell code. But also, for obfuscation purposes, we see that there are other placeholders for different names with the goal of each time you generate a PowerShell payload, Metasploit is going to make sure that the names of these functions or variables are different. Okay, so this is the template, and yeah, we see all those placeholders. And the main one, which is the v64 cell code, here is where Metasploit is going to patch or is going to insert the Meterpreter cell code if you have chosen a Meterpreter. For compiled artifacts is a little bit different because we have two different methods. The first one is more or less similar to what we have seen, the string substitution, commonly known as submethod in Metasploit, and also the PE struct manipulation. So here, scripts don't need to be compiled, but PE files need to be, okay? So what Metasploit does here is it's more or less similar to what we saw with the reflective DLLs, which were pre-compiled and then manipulated. Here is the same. We have different pre-compiled templates, EXEs, DLLs, and so on. And those templates are manipulated by Metasploit. Okay? So, string substitution, the first one. We have pre-compiled templates. Those templates are going to have a buffer with a fixed size, okay? We have the code, we create the buffer with a size, a hard-coded size, like 4,000 bytes. And we also specify a placeholder at the beginning of that buffer with something like payload, which is the thing that Metasploit uses. Once we have that, we make sure that the template executes what is inside the buffer, okay, which is going to be cell code. And that is compiled to create the template. So yeah, I'm not sure if I explained it well, but I'm going to try again. Metasploit has different precompiled templates. Those precompiled templates are going to have a buffer with a specific size. Those buffers are going to have a placeholder with a payload word in there at the beginning of those buffers. So when you generate a payload with Metasploit, Metasploit is going to get the template, is going to search for the placeholder, and is going to patch the cell code in that location or replace the placeholder with the cell code. Of course, since we are using static sizes or hard-coded or fixed sizes, if you choose a payload which is bigger than your buffer, the resulting file is going to be broken. So the caveat with this approach is that we need to use fixed sizes and we need to use payloads whose the size is lower or equal than the size of the buffer. Okay, so now I'm going to show the source code of one of the templates. Source pe exe template.c. We see the fixed size, which is around 4,000 bytes. We see the buffer, which is called payload with the fixed size, and we see the placeholder payload column. And the template, when it is executed, the only purpose of this code is I'm going to thread this buffer of data as a function, and I'm going to execute it. So this is a method of executing cell code from a executable file. Okay. So when you generate exe with MSF Venom, it's going to find this payload column. It's going to insert the cell code here. And when you execute the final exe, the main function is going to execute that cell code. Okay, but bear in mind that Metasploit doesn't do this into the source code of the template. This is going to be built, compiled, and then the compiled file is the one that gets manipulated by MSF Venom or Metasploit or whatever. Okay. So now I want to show how to create a custom template with Visual Studio, because I find really hard to modify templates with Nano or doing it from Linux. I don't really like it. So we are going to see how we could manipulate or we could create custom templates for Metasploit using the substitution method. Okay, so I'm going to open Visual Studio and I'm going to create a new project and then an empty project. MSF 32 exe. Okay. So the first thing I'm going to do is add a new item, CPP file, and here I'm going to copy the code. This is a modified version of the original template. As you can see, the size is the same. The placeholder needs to be the same because otherwise MSF Venom and all the functionality in Metasploit is not going to find your placeholder. But here, instead of using main, I'm using this version with the Windows subsystem, which we are going to modify now. There is a message box, and yeah, we're going to allocate some memory, write the payload data into that memory, and execute the memory as a function once again. Okay, so we need to make sure a couple of things here. The first one is I'm going to choose release, and I want the 32 bits, so that's fine. Then in the properties, if we go to C, all options. And I want to make sure that the runtime library is set to empty, because we don't want issues with the C runtime and so on when executing this in other computers. Okay, and the other thing we have to change for this code is within the linker system, and instead of console, which would make use of the main function, we need to use Windows, because I'm using the wmain one. Okay, so if I go ahead and compile this, it should compile fine, and I have the file here, and I'm going to move it into my Linux. 1 second. Okay, so we have the file here. And this is going to be our template for 32 exe files. Okay, but we need to make sure that Metasploit uses the substitution method for 32 exe files, because it doesn't do it. So we need to do a little trick here. We go to the exe Ruby file, we search for when exe, and here we see that I've changed. Okay, the original code was for 32-bit exes, it was 2win32pe function, but instead I've changed it to 2win32pe exe sub function. Okay, with this we are forcing Metasploit to use the substitution method. Cool. And now I want to change the original template, which is this one. I'm going to back up, and on Atlas, I'm going to move the new template here with the name that Metasploit is expecting. Cool. So finally, we just need to create a new payload with that template. So for this, I have this RC file, and here you see at some point I'm creating a 32-bit listener with the Meterpreter reverse HTTPS stager. The port is this one, blah, 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 blah. And then I'm creating exe for that listener. And as you can see, Windows Meterpreter reverse HTTPS exe with this name. So this generation is going to use the new template I've configured within Metasploit. Okay, so if I go ahead and run MSF console, this should create all the listeners and all this stuff. And at the end, generate, we should have x88 exe file. Yeah, is there. So now I'm going to upload it into, oh, hold on, I'm going to fix this really quick. Okay. I'm going to upload it. And now in the domain controller, we have this file, which when executed should create a message box and execute our shell code. We see the message box, and after this, we see our Meterpreter session opened. And it works. But yeah, this is really cool, but what happens if we try to create a payload, a bigger payload? We try to use a bigger payload for the template we have, the custom template we have created. The exe generator now has a max size of 4,000, around 4,000 bytes. Please fix the calling module. When we use a stageless payload, which we are going to study in the next video, stageless and stagers, the payload is bigger and it doesn't fit in this size. It's bigger than this size. So yeah, that's the caveat we mentioned. So as a note, nowadays the only PE formats that use the sub method in Metasploit are these ones, the exe service, the DLL, and when you choose the exe small for 32 bits. So yeah. And yeah, as a curiosity, of course, when you generate a payload using this method, if you try to search for the payload colon string, it's not going to be there. But if you do it in the original strings template, there x60 Windows exe grep. Yeah, in the original template we are going to find it, but of course when the payload is generated, it's not going to be there because it's going to be overwritten by the cell code. Yeah, there was an update from the Metasploit team more or less recently, some months ago, and now DLLs can use well, there are new templates for DLLs with bigger buffer sizes. So you can, I believe you can use stageless payloads with DLLs. You don't have to use stagers, which was the thing happening before this update. So it's pretty cool. And then we have the other method, the PE struct manipulation. This one essentially it's based on the fact that PE files have a format and have different sections, different things. Okay, so Metasploit has some functionality to parse PE files, and the idea of this technique is I have a parser, I can parse the PE template, I can create a copy of that template, and I can modify the copy to add new things, to modify some things, and so on. So depending on the settings you choose when generating a payload with this approach, Metasploit is going to do things like create a new section for the PE and modify the entry point to point into the new section, or maybe it overwrites the original entry point of the PE with the payload, so when you execute the file, it's going to execute the payload directly, of course, breaking the other functionality. So the good thing about this approach is that it doesn't require fixed sizes, and it doesn't require, therefore, placeholders. So you can use any arbitrary template, any arbitrary file, PE file, and also you can use payloads with different sizes. You are not limited to a specific size set before compilation, which is very nice. So for this, we are going to see the three main ways that Metasploit provides. So we're going to go here. And if you remember, when we were checking the code for the Win32, Win64PE function, we saw the segment injector and the segment appender. So by default, if you create a exe, a 64exe with MSF Venom or any other thing, Metasploit is not going to use the substitution method whatsoever, but it's going to use any of these two, segment appender or segment injector. For the segment appender, which is the default one, we have the code here. What it's going to do is, well, we see here, this is the original PE with Metasm. It parses the original PE and it creates a copy. Okay, copies the headers and exports, and then it creates a new section for the new PE with a random name or the name you have specified, and it writes the payload within that section. That section also is also configured with read, write, execute permissions. And finally, the entry point of this PE, this copy of the original template, is going to have the entry point is going to point to the new section. So yeah, you will have a new PE file with the payload inserted into a new section, and when you double click that file, the entry point is going to be located or is going to point to the new section and to the payload. So the payload is going to be executed. So for this, as we mentioned, we can use arbitrary files as templates. So here I'm going to use Process Explorer, okay, from sysinternals. And yeah, this is an example of how we could use the segment appender functionality. Generate, MSF, sudo MSF console or MSF RC. I'm going to prepare this. Cool. So if no, I have to go to use the 64 one, and I have all the options set. So yeah, now if I generate a exe file, 64 exe file, using the Process Explorer as a template, is going to use the segment appender. Okay. But before executing it, I'm going to explain the other ones. Okay. We also have the other one, the segment injector. So if you specify this setting, the inject setting, Metasploit is going to use the segment injector. This one is quite similar to the segment appender, but without little change. So here we can see a stop of the create method, a create thread stop, okay, in ASM. Depending on if you use 32 or 64, it uses one or the other. So yeah, generate P. As you can see, it does pretty much the same. Creates a copy of the original template, parses everything, copies everything to have more or less the same file, and then prefix, this is for DLL. It creates a new section called .text, okay? And it writes the payload there, but the only difference here is that instead of just modifying the entry point to point to the new section and that's it, the segment injector is going to execute the cell code in a new thread by using this stat. The benefit of this is that we keep the original functionality of the template we are using as a of the program we are using as a template. So the segment appender is going to break Process Explorer and it's going to just execute the cell code. But with this one, the segment injector, we're going to execute our payload and also Process Explorer is going to work fine. Okay, so one way to generate this kind of payload is just doing the same but specifying the keep flag. This keep flag is essentially the inject setting we saw here. The keep flag is the opt inject. Cool. And finally, the last method I wanted to show is the exe only method, which if we go when exe only, we see this function to win PE only. This one is quite interesting because what it does is overwrite the payload cell code into the original entry point of the program we are using as a template. So we don't have to create new sections or to modify the entry point whatsoever. We just need to find where the entry point is pointing to and write or stomp all the data there and write the payload. Okay, and this can be done with this exe only, and we use Process Explorer as well. So we have all the three. And we can upload all of them and see the difference between all of them. So if we execute the appender, nothing happens, but we get a Meterpreter session. Okay, so Process Explorer is broken. We just execute Meterpreter and that's it. With the segment injector, we see that Process Explorer works, and we also have a new session opened. This is because we are executing the cell code in a new thread. And finally, if we execute exe only, once again, the program is broken, but we get a new session. So now we're going to see the difference in the PE format of each of the files. The first one, segment appender. We see that, oh well, let me upload Process Explorer as well. So we see the original file and the other ones. Process Explorer. So you see how in Process Explorer, the entry point is within the text section, which is the default thing that we see, we should see in PE files. Okay, but when we check the segment appender, there is a new section called KP set W, and the entry point is there. Okay, so here is where the Meterpreter payload is located, is patched. Okay. What happens with the segment injector? It happens more or less the same, but the new section, we see we have two different .text sections. And in this second one is where the entry point is located. And yeah, we can assume that, oh, we see the create thread here. The injector is going to first execute the create thread stop, and is going to create a new thread to execute the payload. And finally, the exe only is going to be similar to Process Explorer, as we can see here. The entry point is within the text section, and the location where the entry point is pointing to is the same one, but there is a small difference. If we go to sections, the text section here in the exe only is read, write, execute, whereas in the original file and what we see in normal PE files is that it is only read, execute. Okay, so pretty cool. Yeah, this is the explanation. So as you saw, the generation of executables in Metasploit is not very consistent. We don't have the option to choose what technique we want to use, because, for example, the substitution method is not really good for end users. So any new user that wants to learn about Metasploit, I understand that the PE manipulation techniques are way better, because we don't care about payload sizes, we don't care about what template is used. But for users that want to customize templates and try to get past AVs and so on, it would be nice to have the option to specify a substitute method to use. Yeah, I don't really care the fixed sizes if I'm using my own templates and I know how to change the size of those templates. So yeah, this is something I may propose to the Metasploit team, and I may create a pull request in the future when I have some spare time. So we can specify if we want to use P manipulation methods or we want to use sub methods, and more versatility in that area. So yeah, this is a table that explains the different methods that are used depending on the format you choose. Okay, just for curiosity. And also, well, if you don't want to use the automation process of Metasploit, note that you can also just generate a cell code and format it to different programming languages. So that's very handy. If you want to use this cell code in a C template, in a custom template we've been doing, we can just specify the FC, and Metasploit is going to spit the output, the code, so we can copy paste. So that's useful. And finally, we are going to talk about other frameworks. Okay. For example, the Cobalt Strike has something that is called the Artifact Kit, which is a kit focused or intended for customizing executables with custom templates within Cobalt Strike. Okay, so at first glance, it may look different from what we have been seeing with Metasploit, but in reality, it's very, very, very similar. Okay, because Cobalt Strike does pretty much the same as Metasploit. It has pre-compiled templates for EXEs, DLLs, and service EXEs. Those files have buffers with fixed sizes, and they have placeholders at the beginning, so Cobalt Strike can search for them and insert the beacon cell code in those locations. So yeah, very, very similar or exactly the same as the substitution method of Metasploit. The good thing about Cobalt Strike is, of course, we are using sleep, and we have all the aggressor functions from Cobalt Strike. So the benefit of Cobalt Strike comparing to Metasploit is that we can encrypt with different functions, we can encode with different functions. So it's like Rex, the Rex library from Metasploit, but with steroids. So yeah, you can do a lot of things with aggressor and sleep, and create and customize the templates to avoid signatures and so on. On the other hand, we have frameworks which use the dynamic building feature. So instead of using precompiled files, they use code, and dynamically they write all the specific things on the code and then build the code. So this is something like what we explained about Havoc with the reflective DLLs. So pretty much the same, but for creating executables. This is something we will see on open source frameworks like Havoc, Sliver, Mythic, Covenant, and so on. And with this, we avoid all the limitation from the static templates, like we don't need precompiled binaries with the buffers and the placeholders. We don't have fixed sizes, so we can use payloads with different sizes. And also we have press compiled executables every time we generate one. The thing is, all those open source frameworks, although they have the dynamic building feature, they don't really export or expose functionality to ease the process of customize your templates and executables. Something like what Cobalt Strike does with the artifact kit or Metasploit does with MSF Venom. So they just usually provide a way to export the cell code, and then you can insert that cell code in your own projects or whatever. So it's not really automated. And finally, as a final note that we have seen frameworks and the automation from frameworks, but there are also independent tools that perform this kind of automation. And well, we mainly have Celter, the host payload generator from Outflank, Inceptor, Scarecrow, Pizor, Freeze. All of them, you just need to provide a cell code, and they have their own methods to insert the cell code within a specific templates. They may compile everything or may not. So yeah, it's interesting to analyze how each of them do this thing, because they are very different. Of course, some of them they are commercial, so you won't have the source code of their techniques, but in any case, it's interesting. So yeah, now we understand how Meterpreter cell codes are generated. We understand how those cell codes are inserted within executable files like exes or DLLs. So now, before we move on into reflective DLL or reflective loading, the next video is going to be talking about payload staging. So yeah, I hope this one has been fun. We have seen a lot of things, and I reckon some of them I may not have explained really well, but yeah, I hope you have enjoyed the video, and see you in the next one. Thank you.